So far so good. We have finished the troubling part, and now we are going to simplify the parts. Everything was analog previously, now we are transiting to digital. Not yet, but we are transiting, because now we know how to make logic gates using the have we done this? At least by knowing about diodes and transistors. So before we go far away, we now talk about the feedback. In my culture, we have a saying that those who don't know cows think that the others they burn the others, you know. Anyone knows how what they call this tool here? It's like this, and then here it's sharp. Sometimes designed in a nice way, and it's small. It's very small, not a spear. Anyone who knows what it does?
It's used for weaving.
Weaving what?
Baskets.
How do they call it in English?
In English? It's not.
I see, how do they call it in English? Eh? What? Weaver. Maybe a weaving needle or something like that. So when you get, I don't know how they also call it in English, like you sweat, like I have an upcoming pimple, but if it is a swollen thing and it starts getting ripened, they burn this one red hot, and then they put there, and then the thing, whatever I don't want to mention, comes out. So those who don't know cows, when they see the teats, the whole thing is swollen, they think it is a disease. So so those who don't know this board, yeah, I didn't know the chop, because I was complaining about the chop. When I complained, they broke the board. And now those who don't know the board, chaos. They write like they want scratch or read. This is supposed to write nicely. So if I have the water here, everything will be green again without any problem. But at least so far so good. Okay. In the course outline, I gave you an example of bathing. You refused to follow my example, but I gave you the easiest way to bathe water, cold water in cold weather. That was not the feedback that I want to explain. If you go to a shower, in our hall of residence, we had a shower, one shower which had running water and a heater. I know one guy, I can't mention his name, he would just go, every after lunch, he would just go there and open the tap, the shower, and he stands like for 30 minutes. It was like his therapy. But when you go to a shower room with too hot and cold, and then you release the shower, not release the shower, but you open. If you are this person here, if it is a very cold morning, if it is is a hot morning and you are sweating, you don't care. Just go open the cold side, whatever comes out, it will cool you down. But if it is a cold morning, you open the hot one, you fast put. And then if it is too hot, you now open the cold one to mix up. You put again until when you feel this water is okay for me to take a shower. And that is the essence of feedback. You get this was the output, and this would be like the input. So whatever you feel, the output, this is the input, like this. If I can use this analogy, this whatever is coming out is the output. So whatever you get to feel here, if it is too hot, then you need to reduce. If it is too cold, then you need to open the hot one. So feedback is a phenomenon whereby we can put all or part of the output back to the input. If you are using your phone to feed an audio to your subwoofer, if the subwoofer is funny, like the sound out, then you reduce the volume here. So that means in an essence, you have kind of reduced or added a negative because you are reducing the volume here. It's like you have low back. You had the output, it told you to reduce because the sound there was being distorted. The distortion you were getting on the either E7 or E15, I don't know whichever, when they were saying that increase the input until when you see a distortion on the output. That distortion of when it was supposed to be sinusoidal, and then now you started getting some kind of flat pieces on the bottom. This is the distortion. And then you start, if you were allowed to go back, you would have to reduce, make sure it goes back to there. So we had amplifiers, common emitter, common collector, and common base. And those amplifiers work perfectly if we can know how to adjust our input to get a good output. And in all of them, we were able to get the R out. We were concerned about the R in, and of course the amplification. These were the two things. So did anyone try out my trick? My trick has nothing to do with that. My trick is that make your body comfortable with the cold water. Just get the sponge. I don't know why they call it a sponge. Because the one I use is made up of these small threads. These ones of the shoe. I don't have too many of them. So I don't know why they call it a sponge. It's not sponge. It's not sponge. This is the sponge. So you get the sponge, you make sure it is wet. You put soap, then you make sure you scrub your body everywhere. Now you can even go out free water. But you get, even if it is hot like now and you get cold water and you put, your body kind of reacts and sometimes you get those pimples, you get some rash around. Because your body had to defend itself of that foreign body. But you know, if it is slow, process by process, if you get a frog, and this frog you put it in a pot and you burn slowly, you put that's how you are always cooked. Slowly, they first remove this, they first remove allowance, then they remove the food in the oven. Before you know, they say now we cannot pay you anything. So you put slowly, you put some fire. The frog says it is very uncomfortable, but it is okay. by the time it feels it is no longer affordable here, it is burnt, kind of, it can no longer fly up. I don't know how that process is called. But it's one of the processes. Try my trick now that we are getting into a cold season. You will enjoy bathing in cold water anytime, any weather. So this is the diversion. This is the diversion of the part or all of the output signal to the input. This is what we mean by feedback. The principle bear with me for the first time, but next time I'll come with my domainer so that I don't have to ask. So the principle behind this is that we got the suite where we can add the, so we have the input, then we have the amplifier, common emitter, common collector, or common base. So we shall call it A. And then we finally get an output here. So the principle is that we are going to get part of the output and then feed back into the input. But with some factor. You don't just get it in the whole output, same whole or part. So this factor here, by how much we shall be taking it back to the input, this factor K here is what we shall be, what will determine whether it is the whole of it or part of it. So if K equal to 1, it means that we will be taking back the whole output in so this thing, this whole box is the feedback circuit. And then this one is the factor, this amount here is the factor K times the V out here. Then we fill it, we add it to the input. This will now give us V1. This is the amp. Then this could be positive, we could be adding or subtracting. It could be that I'm increasing the volume of the smartphone towards the subwoofer, or could be that I'm reducing the volume of the subwoofer. That was the definition. This is the principle. We better do some definitions in essence. I don't know whether everybody can see here. Will I be dividing this by 2 to 1.5 or? Yeah. But I'm happy that this one is now, although I still will. I'll still donate the ones with many going up and down. All of them have to look like this one. So when you get jobs, work hard to have extra penny to add on my contribution. So some definitions. We said that the amplification is when we come for a lecture, just 2 hours. Forget about it. Just sit and be attentive. It's for your own good. Because I'm trying to explain, you are busy on the phone. You can't say you're on the or that you are on notes of the course. And I don't think whatever you are finishing with will help you in electronics. It can help you in another course problem if you are revising or whatever you are, but it won't help you at all. You will thank me later when we are done with this course. So the amplification A is the ratio of the output to the input. But this input is not this V in. I want you to understand. We are having V in, but with an option of having the one which will be the part from V out. So for this amplifier here, I don't know whether I said amplifier. For this amplifier here, the input is V1. This V in is the original. You put in the original, then part of it. If you didn't have this V1 would be equal to V in. So the amplification is the V out over V in. And that means that we are not seeing these other things. We are not involving these other things. And that would be open loop gain. Open loop gain. Because we are not involving these other things. Then we have some amplification F prime, which is now the one which includes this one. So you have taken everything inside, so you are comparing the V out and the V in. So this one is V out over the V in. This one will be closed loop. You have involved everything. Remember,
First one should have V1. First one should have V1.
so this is V1. Remember when you were saying using the shops that can we now take the outside loop? This is the loop we are using now. We are taking the loop, everything, closed loop, everything is inside. Then open loop where you don't involve this factor here, we call it that. And this K we have been seeing is the feedback ratio.
I am still not comfortable with it.
Of pardon?
The prime is still not making sense to me. The weight is behind there. I still should be the other way around.
That's how it seems. If I open the loop, this is our loop here. If I open it, if I remove this one, V1 is equal to V. So I will be having the amplification being the same as, okay, sorry, if I open V will equal to V1. But we can't say it's good. We shouldn't get back to V in when we have the V1 which was already here. So with an open circuit without this part, the amplifier here will give us the V out over V in for that amplification. But this other we are calling it L prime, in that it is a closed loop. L prime, when we talk of V out over the V in, then we have included everything. That's why we are calling it closed loop. Still confused.
Because I thought when it is open, i.e. that's when they are not feeding back.
Sure.
So I should expect V1 to be equal to V in.
But why would you even be concerned about the
V1 should be equal to
for this amplifier here, its output V out over the input V in gives you that. Now when you take this part of the V out and take it this way, and whatever, so for the whole, I'm sorry if I now, for the whole amplifier, whose amplification is L prime, then the input is V in and output is V out. And this is now closed loop when we have involved everything. The other definition, so those are a few things that we needed to know. To know the amplification, the other virtual sort of imaginary amplification, and then the factor of our feedback, which is the feedback ratio or feedback factor, this K here. So we have two positive and negative feedback. So let's look at one at a time. And now you see the essence of dustiness, chalk. I don't know whether also we can say dustiness. Chalkboard. Is it now a blackboard or chalkboard? So positive feedback. So I have locked off the damn thing. And, I can still keep it here. So we have V in. We have positive, plus or minus, and then we have the box for amplification, V out, and then we have the factor here, A, and then we have the V out coming out here, and then we have plus or minus, and these are, so positive feedback is when we add to the input. Then we have this one, V1. So we are adding something to the V1. So that means that the input will be the same as V1, this V1 here, and then we are adding on some factor from this. So this will be the factor of V out. And then V out here. V out will be the factor, the amplification factor multiplied by the V in. So V out will be equal to AV1. If we can call this one equation 1, equation 2, so this would imply that if we substitute for the V out as AV1, then we will have that KV out over LV1, which will be the same as, substitute the other parts here. And so we get A over 1 minus K. I came really excited that I'll rush through these things very fast and finish. But everyone is like, it's like seeing stars. We are having V out, which is V1 plus KB out over, V out, which is AB over the V in, which is V1 plus K, V out, which is equal to AV1 over the V1 plus K, V out is equal to A, which is equal to A V1 over V1 in 1 plus K, and this V goes, and this equals to A over 1 plus K. It's natural when it's a two-way. When you are used to hard things, when simple ones come, they look complex. When you are used to simple things, and even when you go to hustle and get the hard ones, you are like, this is already hard. I'm just substituting.
Program was minus.
Huh? Yeah?
It's supposed to be plus.
Plus. Oh, I put minus. And let me first be sure. Being equals to, unless I think I'm the one who made a mistake. V1 should be adding these two. Okay? So this should be V in, and this should be sorry. You are right. So the V1 in will be equal to V1 minus here. That's where we are getting the minus. Thanks for doing that, because I was wondering why, because V1 will be this plus this if it is positive feedback. If it is negative feedback, it will be this minus. So, yeah, so now we look at the negative feedback. Negative feedback, that means we have V1 is equal to, we get the V in, subtract this other part. We are adding a negative part, so it will be V in minus KV out, and V out is still equal to the amplification times the V1, and this would imply usually the amplitude of the amplification is always very large. And the factor Ka will also be much greater than 1. So that this closed loop amplification will be approximately equal to 1 over K. Because if this is very large, very large, then that means that you have this one being minimal. And since we are talking of the magnitude, if we took the one for this one for positive feedback, if this is so large, this is so minimal, so we have this one, I think this one is low, and then we have 1 over K being equal to the closed loop amplification. I don't know whether you remember, but for example, if we take a common emitter amplifier, for example, common emitter amplifier, we have the transistor, and then we have the RE, ground. We have this as the D, DCC, RSA, and then D out. The voltage amplification of the whole closed loop will be the same as the V out over this V in, which will be the same as approximately about minus RC over RE, and AV will be the same as minus delta RE over RE. So why the hell do we do this? Why do we care about the feedback issues? What are the advantages? Why are we concerned about the issue of feedback? They also, the positive feedback also has issues, but not normally is it that you are interested in bringing the positive feedback. So these ones, negative feedback helps us to stabilize again. Stabilize again. And this is when we have gain being less dependent. Being less dependent on device parameters. To find that the architecture of the device is not an issue. We are only looking at what we are pushing back. It helps us to have a more linear operation. In other words, it helps us to have less distortion. It helps us to broaden the bandwidth. Of the amplifier. In other words, we can lower the frequency F1 and increase the frequency F2 for our range of the band. It can help us to either raise the input impedance. So input impedance can be lowered or raised. The output impedance can also be lowered using feedback, negative feedback, or raised. And finally, reduce noise and also thermal effects. And amplifiers. So those are the advantages of negative feedback. We hustled to understand and also to get acquainted to the amplifiers, the common emitter, common collector, common base. Everything was trained. We are looking resistances here, we are looking inputs here, but that was just to make sure we understand the basics. The idea was to make sure that we get the basics of amplifiers. We are not born to suffer. Technology has made our life easy. That's why for those of you who have done D1 and D2, especially for, both of them, D1 and D2, you realize that we can make a logic gate using the diodes, or we find it already done within an integrated circuit, which we normally call the chip. And all you need to do is just power the chip by putting grounding at pin 7, putting VS at pin 14, and you use the components inside without any problem. Similarly, we are not born to hustle, so we can use what we call operational amplifiers, so which some people want to call in a short form op amps. I wanted to be sure so that I know whether you mean locality or it's okay.
So negative feedback usually is to stop this runaway effects of some kind. Or maybe to maintain some but then I'm just wondering here how what is it in the circuit in the K box where you'll be looking at not shutting down the whole thing.
Okay.
If you are subtracting, then there must be some kind of calculating now so that you don't kill the signal.
Sure. It's like I was using this simple analogy of if you were feeding if your input was, you get a phone jack, audio jack here, put it in the subwoofer or Bluetooth, and after you are connected by Bluetooth, let's say you start with full volume here, and then it is becoming allows the output there. And then you start reducing the volume. You reduce the volume until when you really feel the output there is so nice. It's different from if you started with low volume here and you increase. It's okay, you reach there where you want. But then it becomes more of, it's like you are always scared. Like you are not sure of how quickly you are going to get to the best, instead of starting from the bad one to the good one. But the idea is that when you are bringing that, it's a factor, but also when it is high, when it is negative or positive. If that factor is positive, when you are adding it on, then you consider it positive. When you are subtracting it, when it is negative, feedback, but still a factor of the output. It's I don't know, have you done E7? Those who have done E7, how I know the problem is, most of you could have had the problem of the functional generator surging. She's drinking because I phoned them when they were stuck, so I also tried. The thing is showing 0, but we have a signal. Until when I got the technician, so the technician comes and touches this thing, I say, but we were touching, and he said, no, it is faulty. So after you have tried to touch it and bring some figures, don't touch it again. So, and that's where you adjust, and then until when you feel there is distortion. And this distortion is this noise here is not noise that some of you, it's not this noise you make around when you are in a football whatever watching, and it's just anything that feels, it's like a weed. If you grow peas and they are nice beans, they are weeds. And that's how life is. If you grow beans and they are peas, those are weeds. If these guys are praying and some pastor starts praising the Lord, that is noise. Doesn't matter whether it is holy. It becomes noise. So there is this. Sometimes you can have the gadgets, hearing up, because they are trying to. If you play your system at a high volume, definitely you will reach a point where everything is like a bit hot, and that heat can cause some thermal effects and distort your output. I will look for the easiest way to this come out is instead of just in terms of application. See, but the objective is the same, to make sure that you make your system operate at some acceptable conditions, that you get what you want without having a problem. So we look at, I can't figure out the middle, but I'll just guess, and that is the middle. So we look at the operational amplifiers. We call them op amps. That's the electronics language, op amps. So I don't have much to say apart from the introduction I've given, that these are helping us to. So the whole circuit of the common emitter, common collector, common base, whichever of those, now has been ramped down and etched within an IC, an integrated circuit, and then we have a small chip of I think about 8 legs, and that's it. The way you saw that chip, you can imagine if you were, those of you who have done D1 and D2, especially D1, you can imagine the logic gate of using diode logic, even if there are only 2 diodes with our LED. Of course, LED was to show them, but with our inputs at X, Y, and Z for R. If you were to put 6 of those, I mean connect 6 of those, compared to the 6 that are in a chip, those chips we are using the 740002, depending on which gates we are in there. So we start with the circuit symbol. It's more or less like a diode, so we get the sleeping, and then we have an output and 2 inputs. One input is at the negative, and the other one is the positive. The one at the negative, we call it inverting, and the one at the positive, we call it non-inverting. But before that, let me first now talk about the voltages that are on this. So we have, I'm drawing it a little bit bigger so that I can name a few things. So we have the voltages as Vn, and the inverting, Vp, kept ready that, see, this one makes it worse. So this is Vp, that's the non-inverting. Then we, so this is the inverting, non-inverting, and then we have the, here in the middle, we have the input minus and input plus, then we got the output. So this is a diagram showing the voltages, how they are connected to the operational amplifier. So our GRC representative, since you are our MP, Can you talk to the relevant authorities so that taps don't look upside down but reverse water? That's what democracy says. Yeah, so when you go to the when you go to the parliament of the university, as a representative of Canas, you say that our taps are no longer giving us water, so that I don't have to think of carrying my water so that I can now squeeze. Now that we've got a board, you have seen how this board is supposed to be used. Good. I know my rights.
So not a representative.
He was a representative of
Since education.
yeah, but
You want to talk about it?
he will. He will, because he studies here. If he doesn't, then he's still got another year to suffer with the people who use this board looking like as if it is a piece of paper. So how about the IC? How does the integrated circuit top view look like? Top view is you've seen the diagram of the chips. We start from where the notch is. So we have 1 leg, 2, 3, 4, 5, 6, 7, 8. And so we have the at 2 and 3 is where we have the operation amplifier with this one going to 6 and then the 7. So we have 1, 2, 3, 4, 5, 6, 7, 8. This is offset now. Nothing is connected there. This is offset now. Nothing is connected there. 8 is also not connected. 7 is where we have the positive voltage. Then the V out is at 6. And then at 4 here is where we have this input here. So this is V minus. And then it is inverting here, non-inverting. Once we have that chip here, we have this operation amplifier, and we can do amplification of whatever we want to do. And not unfortunately, but we don't have any of the experiments of operation amplifiers in our menu. Didn't get any. Sorry about that. I wish we could do all the practicals. Those manuals were our time. We had all the practicals as a course unit. Only practicals only. We had a course unit called practicals, and we would go to the lab and just chop practicals from all of this. So we do some definitions. P is a non-invariant input. explain to you one plus, a plus times a plus equals a plus. Plus times minus or reverse equals minus. And minus times minus equals plus. Is that? The first bit like this follow meaning that I did. I gave you a story of the woman with many kids and the woman with no kids. Simply, if you are broke and you meet a friend and you say, today I didn't take lunch, and he's like, oh, I left some and even poured away. How do you feel? You are broke and the guy says he even threw away some. You feel terrible. And if you are broke and then you meet a guy and says, at least for you ate cassava, me I had nothing. You even feel, your hunger goes away. You're like, this one has many. That's why when counselors, I don't know whether all of you, apart from DSC, are doing psychology. When you are counseling, you have to first put yourself. If somebody says, me, I'm tired of the world, I want to kill myself. And my father even doesn't give me pocket money. You say, me, I grew up when I have no parents. So they start coming down. They are like, maybe I can assume that these parents and my dad is not there. And if it survive, if this one survives without even a dad. So they make sure that they come to your problem. You have problems, so they also try to come to your problem so that you start relaxing a little bit. So N is inverting, it's a negative, so it's inverting input. That's why they advise you that keep away from negative energy. There are people who are negative. You say, when I grow up, I want to be a big important person. You can never be. You know, it sounds like you can ignore, but if this fella keeps doing that, you will never. So, for me, I don't tolerate such nonsense. I tell you that I can, like the way I was telling you that I will bring a new I should donate a blackboard. Then some of you are like, actually, before this blackboard came, you remember when I complained that day when I taught at 11? When I left here, I wrote our WhatsApp group of the university. I said, has anyone also experienced fake chalk? By the time I was going to go for my lunch at 12:30, they were now fixing the board. So in the evening I came and tested, and it was the board I know, which should be comfortable. But there are people who are saying, just use the chalkboard as it is, you will be fine. Those negative, that negative energy is inverted. And so then we have the V plus and the V minus. If you remember, if you have done any of those practicals where you have to, I don't think there is any practical which does that. You only have positive 15 or probably positive 12 for the VCC, but there is an experiment. I don't remember which experiment it is, and I don't want to check, but whereby you need to put the positive 12 and negative 12. And these are the DC power supplies. This one here, these 4 and 7, and usually they are in the range of plus or minus 12 or plus or minus. It doesn't matter whether you are here in China, in the US. The beautiful thing about most of the science, it's universal. Even when if you do anatomy of an African person, the blood is the same, is red. The heart is the same. I don't know why we even care about racism. You know, can't ask which meat, this is meat of which cow. You just chew the beef. Same as apples. Apples, when you look at apples, the brown ones, yes, the brown ones are always like spongy. Whereas the green ones are a bit tight. But the taste is the same. They are apples. So, then the BD still can see here. Still can see here. VD differential voltage is equal to the difference between the T and the N. And this is called the differential input voltage. Differential input voltage. And then we have the AD. D is for differential, so this will be the same as the V out over the V in. That's all we got. We got the V in here and the V out here. So this would be the same as the V in is the differential voltage, which is the same as the differential gain. What did we call this? Open loop gain. When we get this over this here, we are not considering anything that we are going to make around here. We shall be just looking at V out over the differential voltage here, between here. But soon we are going to be connecting resistances here for the feedback, some for input, for different configurations. What is the equivalent circuit? So equivalent circuit yeah, people is one trouble. Or is one problem. One problem. They are lucky, some of you are lucky. COVID met me a bit. I didn't get, maybe I got it, but I didn't get COVID. But COVID made a lot of changes in the way I look at stuff. So, and also it changed the thing, because when I'm here and I'm teaching, all of your phones will be away. And same picture. We agreed that computers have to be closed when I'm teaching. Because I don't think you are looking at what I'm teaching or getting going for. So an amplifier at the input. So we had the input voltage here, and because we are having the, I love this, but because we have these two voltages here, so we can say this is VP, this is VN, and this would be differential voltage, and this would be input impedance, which we gave in some. So then we have this voltage source here, the AV, VD, Z out. All of you, I don't see, okay, not all of you, but as a student, I don't think you have any emergency call that you can't continue with the lecture. Because what can you do? Even if they say there's something terrible has happened to somebody, you are not an ambulance driver. So you would better just relax and study and concentrate, and then when you are done, you can attend to your phone to see where you have a missed call or something like that. So this would be the V out, and then we have I2 here, we have I1 here, and then we said that the whole of this box here, including the V out, was our amplifier. This one goes. So all this is one is within this chip. And this chip is where you have input impedance, output impedance, voltage source here, and then we only see the output here and this differential input. Then we power it at 7 and 4, then we input at 2 and 3, and then we get the output at 6. 5 and 1 are offset now, and then 8 is there, is hanging. So Z in is the input impedance. And then Z out is the output impedance. And then we need to know if we have an ideal operating amplifier, what makes it ideal? A perfect. What makes an operational amplifier perfect? Ideal op-amp. When I would be watching YouTube videos, you would see a guy writing, everything he draws is very nice. Assumptions. The assumptions are that one, you can guess some, because we did talk about them when we were looking at the other amplifiers. What should be how big should be the input impedance for you to be a nice amplifier? Very perfect, ideal. For you to have a perfect amplifier, how should its input impedance be?
The input impedance should be be too low.
The impedance is resistance, the input resistance. I want you to feel at home first. We're engineering. The V out over V in is the amplification,
Yes.
but we are talking about the input impedance. Impedance is the same as resistance. We call it impedance if you have a bunch of components, resistances, capacitances, and resistance. So we round it up as impedance. But let's talk about resistance. What should be the size of the input resistance if it is going to be a perfect amplifier?
The input resistance should be too low to make sure that the amplification is high.
So if it is too low,
Yes.
what happens with the current we are inputting?
It should also be too low.
Would it consume it or not consume it? If we have low resistance, what happens to the input current? Does this amplifier consume it or repair it?
It will be consumed with.
It will consume it.
Yes.
Is that a good thing or a bad thing? What I'm trying to do, did they say competence based? I'm trying to make sure that you are the guys. I'm trying to make sure that you see logically, not cramming. I don't want to state stuff here and quickly talk about these are assumptions and then you are like, yes, I've crammed them. It should be logical. If you have no resistance, you allow the current to go through. And that means you are consuming some of it. And if you are consuming some of it, you are deterring it to be used somewhere else. So you should be having too high input resistance that nothing goes within the amplifier itself, but to the system, whatever is connected to the amplifier. So, but we start, so that is the input resistance, but what should be its gain or its amplification? Should it be small or big? If it is a perfect amplifier,
It should give us a big amplification.
it should be huge. So it's like infinite because we are looking at it as infinite, as perfect. And then output resistance. Those are the three things. I wrote them here. We have Z in, we have Z out, and then we have A. Those are the three things that should come to your mind when you're talking about amplifiers. The input resistance, the output resistance, and then the amplification. It should have a high input resistance, never to consume any current. It should have a very low resistance in order to make sure that you can connect whatever you wish to connect on. And whatever you connect on should be able to benefit from your system and should be able to amplify as much as
Sun.
one is infinite gain. And infinite gain, the gain here, we are using ALD, differential gain. And this is what we are saying that is approximately equal to infinity. And just for purposes of information, the typical values of this gain are about 10 to the power 5, a million, 10 to the power 6, or sometimes higher. What is the consequence of this? What is the consequence of having too much gain?
If there is any noise,
So the consequence of this is that the VP minus Vn would amount to the, or would be equal to the V out over the VB, and what would this equal to? The AD is the same as the V out over the differential over input is the VP minus Vn. So we are saying that the VB, okay, which is V out over VB. So what we are saying is that this VB, which is equal to the VP minus Vn, would be equal to the VD is equal to V out over AD. And we have said that AD is infinite. So that means we would be having V out over infinity. And this would be equal to 0. So this is equal to 0. Or VB would be equal to Vn. When you have infinite when you have one sweet and you give it to a whole of Uganda, no, some of the people may not even feel anything. So it's like getting 0. So anything out of infinity is 0. I jumped a step here, which I have explained here. But VD is VP minus Vn, which is equal to, from this formula here, the VD is equal to V out over AD, which is equal to 0. If that is the case, then you will have VP equaling to.
So for this one, VP equal to Vn is tantamount having the high gain.
Yes. The consequence of this assumption that an ideal operation amplifier has infinite gain is that the two inputs are the same. They are equal. If they are equal, then you have infinite gain. Yes. This is where it comes from. This is the definition of the amplitude. Of the amplification is equal to the output over input. Our input is a differential input. The voltage across the inverting and non-inverting. So, if we did by definition, this differential voltage here is the same as the output if you go small slab. So it should be equal to V out over AD. But we have already assumed that this is too huge. So this V out over a huge value, infinite value, gives you 0. So this assumption 1 gives us that the VP equal to here. It should be AD. Yes, I think you are right. So I have been seeing this as AD. The problem, did I ever say this? Especially those of you are doing, since you are doing education, be precise to the point. You know these kids, have you done NSP? So in June you will get the dose of what you are doing to me. A kid will just sit and say, sir, after you have filled the whole body with x cubed, x squared, dx, dy, say, is that x cubed or x squared? With the full board. The blackboard is full of everything, and then the kid just asks you that. And then if you are fake, these people want to show that they know. You start now looking around. Then you start, don't waste time. Tell your kids to say on the second line, is it x cubed or x squared? So that you go straight to where there is a problem. So now he said on that equation, is it, so for me, instead of saying that you are still having VD instead of AD, and you are explaining divided by infinity when it is VD, now I'm like, yeah, because in my mind I know there is an AD there. I even emphasize it here until now I find actually I got VD. So as teachers, please make your life easy. And those kids don't, that's why I've always happy. Those kids will punish you for me. I hope I will teach you in third year. Some of them are sons and daughters of rich people who can decide whether you remain in the school or not. If they say we don't like that, one like this says, I don't like that guy. Just check. If you are lucky, they put you in another class. If you are lucky, if you are unlucky, they give you express. 2. What I was asking about Z in is infinite. And so Z in is approximately infinity. Typical value of what we can consider infinity is about 10 to the power 12 ohms. How do you call this one in terms of mega, giga, tera?
It's called tera.
So these are tera ohms. What is the consequence of this? The consequence of this is that we say that there is no current errors, if it has an error, nothing would leave. No current errors or leaves, either input. When we say either input, we mean VT or at N or at E. Third assumption is that Z out is negligible, almost equal to 0. That is very small input impedance. Consequence, the consequence is that the output voltage is in 10 and output voltage is in 10 of the load. Doesn't matter what you call it. But it is hard to find ideal things, okay? So this is how a real op-amp would look like. have the differential voltage in millivolts. Because we are doing, I think, still E7, where you have to put in about 20 millivolts. But that's for the amplifier, not the big amplifier. Like the one in that experiment. And then you will have this, with this being about minus 12 volts. This being about 12 plus 12 volts. So we have this being ideal, this being real, this one being V naught. V naught is the input offset voltage. Tomorrow is Amplifiers. I wanted to finish everything today. I mean everything about these programs. I doubt I'm going to be able to. So we know how an amp looks like. We know its circuit symbol. We know the voltages on it. We know the top view of the whole IC. We know the equivalent circuit with an input impedance, then output impedance, and then the voltage source. Then we know what an ideal op-amp is. We've now looked at a comparison with the real one. And so, we look at the basic op-amp circuits. With the assumptions at the back of our mind. Input impedance very high, so that nothing else, nothing gets out. Amplification very huge, infinite. Then output impedance so low, like that one of the speaker. Remember when we said like that of the loudspeaker? And so let's start with the first circuit, which is an inverting op-amp. So we connect the resistance, okay, we connect our input on an inverting terminal. So we have the input here, then we on the inverting terminal here, and the minus here. Here, we put our input there. Then on the, we ground the positive, inverted one. So this is the Vn, and then this is the Vp. So we ground here, and then this output here, we feed it back to the input through a feedback resistor, RF. So this is the V out, this is the RF input resistor. This would be the current via the feedback resistor. And if this was our R1, this would be I1, and then we are getting everything from an input, which is the input. And that's it. So this is Vn, Vp, R1. So this is the reason that we did study about Kirchhoff's laws. We have nothing to do, not so much this side, because everything is grounded here. All we can think about is what is taking place here. So at node here, at this node, Vn, we have the I1 and IF meeting. And when they meet, our assumption is that nothing ever enters, no current ever enters the amplifier. If it is an ideal amplifier. So I1 plus IF is equal to at Vn as a node, I1 plus IF equals to. That's why we say that there are some things we have to keep at the back of our mind. Because by whatever case, you will have to use them at one point. And it doesn't matter when you have two, but you have to use them back anymore. If I wash this thing, I wouldn't be hustling like I'm hustling because all this will be gone. By now, I will be cleaning like a boss. So the rest is now algebraic gymnastics. I1 in terms of the voltages and the resistances is the same as Vn minus Vin. Where is it flowing? And which one would be subtracted from the other? It is flowing this way, so current flows from high to low. So this would be Vin minus V1 over. And we are adding one V out, it is going from V out minus Vn over RIF, and this is equal to 0. Our initial is to find the amplification in this case. Vp is grounded. What do we find there? Vp is grounded. So what is the value? 0. So Vp equals 0 because it is grounded. And This implies that VP is equal to Vn, and what would be Vn now? From the other assumption, when we say the AV is infinite, and then we ended up dividing by AD, which was infinite, and everything went to 0, so gave us VP equal to Vn. So if VP is grounded and is 0, so is Vn. So this implies this is equal to this, which is equal to. So we have this, sorry, here. So this one is 0. So we will end up having that ends. But do I have anything 1, or this would be Vn? Yes. So that means that we have 0, 0. So we have V over R1 plus V out over RF equals to 0. So V in is equal to minus V out of RF, and our interest is AV, the amplification, which will be equal to V out over V in, and this will be the same as minus RF over R1. So you can find the amplification simply once you have that circuit. You don't need to do much. You just have your RF of R1, and the amplification should be minus. Second case, or second circuit, is a non-inverting, meaning that the input is at the VT. So non-inverting op-amp. I have the input at the non-inverting. This is the V in. And then we have the V out. Then at the inverter, we have the potential divider here. So R1 and R2, V out, V in, and then we have this Vn. Vp is equal to Vn, so that's what is coming on. And then Vn would be, what is Vn equal to? What is Vn equal to? Yes, so it is encompassing in terms of this loop here and this loop. It is encompassing R1 of this output here. So that means it will be the same as the Alex. I don't know what I will do to you. I'm busy explaining this loop and this class. He's enjoying the messages he's getting. He's reading what? These things?
Yes, he's doing that.
He was doing this what?
Yes, he can do that. Going to
answer did you give to Joe?
I just see you every time you complain. But she's
I don't, Joan, I don't complain. I lose nothing when I leave him to be absent-minded. Okay? I lose nothing. I want you to get that. I can come here and do my stuff. I'll still be paid. I'll even have more peace. But inside me, because I'm a trained teacher, I am here to impart knowledge to people. Even you sitting there and you just keep looking at me, I just didn't want to have problems. But from the time you came in, you just sat there, you may think it is okay, but I told you, you hear, you forget. You see, you forget. You do, you remember. Agawa writes everything. He's here on time, he writes everything, he's attentive, he asks questions. You think he's a fool? He has a tablet, but he has never been on a tablet when I'm teaching. I don't get an extra penny by being on your case. They don't increase my salary. But I've met students whom I have hustled up with and I see them better. And it hurts me to find that, as if when I want you to work hard, it's like you are being on our case. I looked after goats, I told you. When a kid is a young goat, when a kid has just been born, and you are trying to hold here, this is a kid's head. If you hold here, and you want him to go and start suckling the teeth, it will resist, so you just lift the legs. But the moment it grabs the teeth, and you want to pull it off, it will go with it. Unfortunately, it is not having the teeth at that level at the beginning. I have seen kids, I have tried to make sure they work hard. And once they click that this is what they should do, I've seen them progress. So you can't tell me that I'm busy explaining this potential divider and somebody has finished it and is already enjoying it, enjoying that this is some of you, because I smile, I talk, I can come here. I've ever taught a class without saying anything, without saying anything. Students disturbed me, I said, okay, by law I have to teach you, but I'll be talking through writing on board. So I would come and say, good afternoon. Then I underline, then I write my stuff. For a week, until when they all wrote apologies. The whole class, I have a file of those apologies. I don't believe that you can, even if you have everything, even if you have downloaded everything on the phone or the laptop, I don't believe you can come here and sit like this, watch me. You think I'm what do you think I am? To come here, even I have to look for a duster that can make the code clean. I write everything. I'm a human being. I would also love to come and say, can you open on the other page? You see that diagram, so I chop a little bit. Africans, if you don't push anything to Africans, they get nothing. You'll appreciate my efforts when I'm done. And when you come to my office, look for difference, I'll just smile and say I'm not present. Because you would have given me headache here. So Joel, you don't need to explain to me anything. I know what I'm doing. I've done it for a long time. And I can see a student, I know that this student is following his heart or is just lost. like same. Okay, let me finish this part and then we go on. So we say that Vn would be, this one is encompassing this part of the V out being divided by these two. So it would be V1, sorry, R1 of R1 plus R2 of V out. Now that we have the V in and V out, we can find the amplification. Yes? Then? The devil. V in this one here, you still have to take it as this, like you are thinking of it as something which is connected to the ground. If you are here, then the other part should be ground, in order to be talking of that as the Vn, okay? You can't just say have it, just hang it. So is this one. To the ground. Okay? VP is the same as V in. Yeah, this is the VP. It's a non-inverting, so we connected our input on the non-inverting terminal, which is the positive terminal. And that is why I was saying that you need to be near people who are positive, who have positive energy. When you say, I want to be a minister in the future, you say, yeah, you can actually become president. And you are like, yes. When I just come here, the one thing I appreciate about, if I say, I appreciate about Baganda, people will say you are being tribalistic, but whichever buffer I would tie in Uganda, they never laughed at me. I would say Obakedo Yange, but instead of Wange, and no one would laugh at me. Any buffer I would tie, they would not laugh, but correct me. But there are people, when you tie a buffer in their language, they laugh off their head. It's like, and I think that is, I had started trying to learn Chinese, and this Chinese were I found it very stupid. You know, you pronounce their word wrongly and they laugh at you. Like they are like, this is not hard. But when they also time buffers in English, so I left the course. I left the course. I had tried to be very humble so that it make you sing, you sing. But when now it came to, you know, as if we are stupid to learn the language, but themselves, they cannot speak the English I speak. When even English is not even my mother language. And they think when you mispronounce a word in Japan, in Chinese, it's like a big thing. I just broke out and said, after all, I start to be too. So, sorry, good man, I have understood. But this is how we are looking at this potential divider. That this V out is covering this small potential here, and this one is only covering this other one. And then we have that VP equals Vn. This is the assumption. Remember, all ideal op-amps, the assumption remains that Vp is equal to Vn. And this would imply that the amplification is equal to V out over Vn, which is equal to 1 plus R2 over R1. We can have a special case. And this special case is when we have R2 equal to 0. This will imply that if R2 equal to 0, what happens? is the case, V out will be equal to Vn, because it will be equal to Vn, but Vn is equal to Vt and is equal to, and this would qualify to be voltage follower. Remember when we are talking about the meter follower, and this is how we can draw it. We have the non-inverting here as Vn, and then we have the output coming to the non-inverting. This one being equal to V out, which of course is equal to Vn. We shall look at the summing, integrator and differentiator tomorrow. And I hope by the end of the week we shall be done. And now the speed will now start being higher, because the digital electronics is now, most of you are at home digital guys. So I have no complaint with the chalk, I have no complaint with the board. I have a complaint with some of you who think that I have nothing to do but to care about your future. But I promised you from day one that I'm a pair. Is it pedant or pendant? Pedant. I am a pedant. I assume that you don't know what brought you here. I assume, I'm not saying that I think or I know. I assume that you don't know what brought you here. But you may know what brought you to Makerere, but in electronics, I'll assume that you don't know why you are doing electronics. And I'll make sure that you become attentive in order to perform better in this course. And also benefiting from the course at the end of the day.
Excuse me.
Yes.
Perhaps when I did this profile, I tried to access the offline assignment.
There is no offline assignment instructions. They are just on that week where there is an alternating lighting transistor with that silent thing. There are instructions of the principle, operation, in comparison with the BJT. And then the link is for you to upload.
Yes, that's what I
So the instructions are you type a few pages, maybe up to 2 pages of your work about FETs. That is the structure, operation. Don't remember the other thing. But if you want instructions, I'll put I can upload there a page of instructions in but they are there on the page. And then the 100 numbers are now active. You can start playing around with them until when we are done. Then you will be able to. I'll take the highest grade. This time I'm very generous. I'll take the highest grade. See you tomorrow, both at 11 and at and even if power goes, D1 and D2 you have to do. Even D14 you were supposed to do. But those of you who are supposed to do D14